So as I was saying, I get to talk to you about a vision for Bristlemouth education. I love that I get to work in experiential education because my students get to do that really speculative research. That's so fun. We work with students from a diverse nature, both here in the US as well as internationally in places like the Philippines, Honduras. And so they get to test a lot of crazy ideas that we know most of them are not going to be practical, most are going to fail, most are not going to scale. But every once in a while, that incredible diversity comes up with some really interesting ideas. And I love being able to figure out potential financial mechanisms to scale that forward. And that's what we want to do with Bristlemouth. So in 2024, I got to test the pilot program for Bristlemouth education in high school. In thinking about how to do that curriculum, what was really interesting was to think about that these students are going to be retiring in the year 2070, starting their careers in 2030. And so how do you design curriculum for them in a world where in 5 years, we don't even know what the tech is going to be necessarily, with how quickly AI is advancing everything, with how quickly we're seeing the effects of climate change. So I really believe the best way to do this is in a workshop setting. Put the emerging technology in their hands, let them ask the questions, let them figure out the solutions, and do it early on. And that's really what we've created. That also advances the goal of Bristlemouth, which is to become a marine standard, right? What better way than to put this in the hands of high school students, undergraduates, graduate students on capstone projects. So when they enter the workforce, this is the platform that they're comfortable with, that they're using, they're innovating on. The curriculum we're looking at has 3 components. It's an adaptive learning program, which will be available online, free to everyone to download and work through to learn Bristlemouth and how to innovate on that platform. Also, classroom workshops where we'll have a scaled down version of the spotter and the moat. We don't need the satellite for the classroom. We could run off Wi-Fi. We can have a scaled down version that also comes with consumables so they can play with the hardware, innovate on their own. And then if they develop something that passes some of the feasibility tests, we can deploy them in real world situations around the globe on 7 different spotters that are ready to take whatever they are able to develop. All the data is going to be open scientific data, open source development, available on Aqualink as well. So even if they fail, are they really failing? They're providing design notes, they're pushing the educational component of this forward for the whole community. When I mention the e-learning, when I say adaptive learning platform, this is a machine learning LMS system. So the idea is this is how we're going to address the issue of, I mentioned high school students, but early professionals learning the Bristlemouth is the Area 9 platform. It has a component to it where as you go through the different modules, you're saying how confident you are in the answers. It's monitoring how correct you are, and it tailors the learning experience for you. So if we set this up as a 6-hour program, it might take a high school student 12 hours to work their way through because they're doing remedial work at every step of the way. And if you have a junior level engineer, they might take 1 hour to move through it because of their background. The workshops I mentioned, I did want you to hear from the students. So I asked them what their experience last year was working with the dev kits.
I have to help my community more through, and not only my community, but also the world trying to through the environmental issues that we have. And through the dev kit project, I have been able to try to understand.
Okay, while we figure out the audio component of the video, I did want to point out when we go into a new classroom, we share with them the stories of what the researchers in the field, what they're really working on and what they have a need for. So some of the time this might be their classroom chooses to develop low-cost sensors for water quality to affect how the local government monitors new development. It might be part of a coral restoration project. So that's one of the things that all the work they're doing is tied to real-world work in the field. I think we have audio back.
So we're gonna get Marcus up here to help you with the audio real quick.
Okay.
Thanks, Sarah. Ready?
While they're getting that ready, so Vince approached us with a Pioneer application that was like, I'm going to take Bristlemouth to high school students. I was like, oh boy. He's like, no, really? You don't know, you don't know these kids. And I was like, there's no way. I'm struggling with this. But they pulled it off. They not only were they able to program our basic programming, but they were able to integrate their own payloads. They taught each other how to do it. They posted on the forum. It's just incredible. You guys ready with the audio?
And pulled it off. We got as far as putting the prototype hardware in the pool at their high school, which was really cool. And I think what we're sharing today is if we could go back in time and create the program we wanted to get them to the place of doing real world fabrication and having results, this is what we're sharing.
Yeah.
Yep. Sorry.
Let's see. Oh my gosh, there it is.
During my time at my high school, I would like to go and help my community more through, and not only my community, but also the world through the environmental issues that we have. And through the Dev Kit project, I have been able to try to understand where we come from, what our problems are in the world, and how to solve it through a engineering aspect.
Seeing how engineering can be applied to the fight against climate change. It seems really obvious now, but I don't know why I never really sort of connected the two as something that could be intertwined before. But I think having the thought that my work was helping the global community sort of sitting in the back of my mind when I was having a lot of trouble sort of programming or something really helped push me forward, and also brought me this sort of sense of fulfillment that I hadn't had working on my projects and like my engineering classes before.
First of all, it was a new experience to me and pretty much everyone in the group, because we were working with a small team, and it was being a whole new project, so of course none of us knew really how to do this. And I found this sort of a really unique kind of experience, which I really enjoyed. And it was an experience I wouldn't get in school or anywhere else like that as well.
And I can see a lot of value in a future class that contains these things, because it's a great way to get kids into learning about coding and engineering while also getting them to care about the ocean. The bleaching epidemic can seem a little abstract when it's not right in front of you. I wasn't truly able to comprehend the scale of it before I went on the expedition to Bonaire. But seeing the numbers rise in front of you on temperature and turbidity, it can help people wrap their head around the climate crisis and make it a little more concrete. And as someone who's never taken any additional coding or engineering classes, I can confidently say that this program was the first time I ever started considering engineering as a possible career path. I went into this program with no knowledge about coding or anything like that, and it was really difficult work, but it was some of the most rewarding I've ever done, just from knowing I'm making lasting change, but also completing the coding sections.
This is the future blue tech.
During my time,
The next phase of this project is going to be to design that adaptive learning platform so it can scale to colleges, to professionals. We are still looking for sponsorship for this project. This is through a nonprofit, and as I mentioned, this is all going to be available open source, open science, to the public in general. If we hit our target of getting the funding in Q1, we want this to be ready to go this fall, meaning to be in classrooms this fall and available for download on Bristlemouth and other sites to everyone, with a 2-year goal of hitting 100 classrooms, reaching 1,200 students by the end of 2026. Our financial goal to get started is 340,000, and that's both for the development of the online program as well as hardware, both for the classrooms and in the field. This is a community project, so we're going to be on the forum as well. And so if anybody in the community wants to have input into the educational program, please reach out to us. And you can follow along both on the forum, and of course, my QR code is right underneath the little screen. We put up a web page that you can get into contact with us, give us feedback, follow the project as it progresses over the next couple of years. So thank you, everyone.